afternoon, we have three dynamic personalities in the tech space who will be walking us through various issues: how ISPs work, network engineer career paths, and how to develop an ISP IPv6 implementation plan. And beyond that, we will also get into very interactive Q&A sessions. I ask that you stay up for that. You will understand how KeNOG was formed and where we are going. And we'll also interact with you through running polls so that you can give us feedback and we can see where to improve and what we can feature in future webinars. My name is Martha Morioki and I'll be moderating today's webinar. So before we start on the presentations, I would like to first introduce Kevin Chege. You've heard him doing sound checks. Kevin is the Director, Internet Development at ISOC, and he has more than 15 years in the industry, so he understands this industry very well. Kevin will walk us through the journey of KeNOG, where it's come from, and where we're going. And with that, Kevin, I hand it over to you.
Okay, thank you. Thank you very much, Martha, for that introduction. So good afternoon, everyone. My name is Kevin. I will give a very brief presentation just on the background of KeNOG and how it came to be. This is a presentation done by myself and also Simon Mayoe, who's also part of the KeNOG co-chairs. So the goal of this was to come up with a platform focusing on network operations. It's something that had been discussed in the committee for a very long time. And in 2018, Simon and I and a few others put together a small event just to gauge the interest and find out if there was a community. In 2019, we had a larger event. This was October last year. We had more volunteers leading the work and also more people helping to organize the event. Our conclusion was that there was a lot of interest and support being sponsors both local in Kenya and also outside. Perhaps also a few skill gaps which we could look at addressing. There's a link there with the reports of the activities of 2018 and 2019. So what we decided to do this year after those two events is reach out to the community, and this was just through a WhatsApp group, find out who else would like to come on board and play a role in organizing and leading. The feedback was to change the name from Tech Week to KeNOG. We ran the two events as Tech Week 2018 and 2019, but after discussion with the new team that came on board, it was decided that a change in the name would be good, so it'd be easy to identify with operators, also the audience we're trying to reach, and also the sponsors who would like to work with. We collected feedback from the community. Again, this was on the WhatsApp group. We used that feedback to identify activities which we could focus on this year, content we could cover, and also possible intervals to do the work. So what is the goal of KeNOG? It's mainly to enhance local technical capacity in these 5 areas: network operations, internet services, internet security, automation, storage, and cloud-based services, and provide a platform for knowledge exchange and interaction. Now, we do know there are other communities like this, but KeNOG is trying to sort of bring all of them together under one umbrella so you can easily find each other. So what is the plan? Based on the discussions with the program committee, the volunteers who are leading this work and the input collected from the community, we're going to focus on those 5 topics. Our urgent plan or immediate plan is to do monthly webinars just like this one. The webinars will take the form of having 3 presentations, including Q&A. And then we are going to have monthly tutorials between the webinars. Now, the difference between a webinar and a tutorial is that a webinar will be more of an overview, and then a tutorial will be more in-depth, more training-like in nature. So you can expect to get more knowledge there, maybe even to the level of getting configuration samples and so The webinars and the tutorials will vary from basic to advanced. So this is an introduction to what you'd call basic level content. It's introducing how ISPs work and IPv6 and career paths. And our plan is to work with the community to identify the topics and also identify the experts in the community, because we know in Kenya we have very many experts in all of these 5 tracks that I've mentioned about. So we're looking to have a lot of help and contribution from all of you and from the community. There's a WhatsApp group, which the link will be shared on the chat. You can join. That's where we are doing a lot of the discussions and engagement. Please share your thoughts in the polls and in the surveys. Your feedback will really help the volunteers that are leading this work to improve the work going forward and adjust to match what the community wants to learn about. If you're an expert in your field, please volunteer to speak in a webinar like this or to lead one of the tutorials. That would be great. If you're able to sponsor the activities that will come in the future, that would also be great. All the activities that were done in 2018, 2019 were supported by sponsors. And you can reach the program committee, the PC, via PC at KeNOG. And if you go to the KeNOG website, you'll see more about the 2 events that were organized in 2018 and 2019. And thank you very much, and we look forward to engaging with you. Back to you, Martha.
Great, thank you, Kevin. And as you can hear from Kevin, this is a volunteer-led community. And so it is a call to action. If you have expertise and you can share within the tech community, please reach out to us and we will give you a slot to be able to lift someone else up. All right, without further ado, I would like to lead us to the presentations. We have 3 industry experts and they're going to make presentations and answer your questions. And we shall take the questions at the end of each presentation. There'll be very interactive Q&A sessions. Please feel free to type your question in the Q&A section. You can either do it anonymously or you can indicate your names and maybe your place of work. We shall also run polls. I think if you check on the poll section, you will see some questions already there. Please do contribute, and it's through your feedback and rating that we will be able to build more interactive, more useful webinars and tutorials in the future to build your needs. That's it, let's get into the presentations. So our first presenter is Michelle Opio. And Michelle has 8 years of experience in the service provider industry. Currently, she serves as a senior network engineer at Work Online Communications. Michelle is very passionate about the African internet connectivity landscape and more so about developing young talent. Michelle volunteers as a trainer in various regional technical and forums and NOGs. And today, Michelle will train us. She will impart some knowledge on us, giving her expert opinion on how ISPs work. And with that, Michelle, please take it up.
Thanks, Martha. Hi, everyone. Welcome. Just want to quickly share my screen. My bad. Okay, here we go. So can everyone see this? Okay. So as Martha mentioned, my name is Michelle. I work for Work Online Communications as a senior engineer there. Just a brief overview of Work Online. Work Online is an IP transit organization. So what we do is we provide network services to other network providers. We have a global network. It spans through Kenya. We have Nairobi, Mombasa. We have POPs in South Africa as well, in Cape Town, Johannesburg, Durban, as well as Singapore in East Asia, and Marseille, Frankfurt, Amsterdam, and London in Europe. So that's the span of our network, as well as a POP coming up in Ghana. So we're going to go right into it because we don't have much time. The objective of the talk is to just take you through how internet service providers interact with the internet ecosystem, locally, regionally, globally, so that we can provide these internet services that we all use. And also mainly to understand the concept of peering and transit. So what we'll do is we'll start with a couple of definitions. Just indulge me because I'm not so sure who is on the call and what their level of interaction with ISPs is. So we'll go through a couple of definitions before we get into probably the meat of the presentation. So to start with, what is transit? So transit is basically just carrying traffic across a network, and usually for a fee, right? Peering is exchanging routing information, usually between two networks or more, and usually at no fee. The default is basically where to send traffic when you don't have an explicit match found in your routing table. So there are a couple of things you need to do in order to achieve peering or transit, right? Some of the things you need are IP addressing. So you're going to need a globally routed IP address space. And this is a resource that's shared amongst the entire global population, right? So as such, there is an entity that is responsible for assigning these IP address spaces to all the providers, and in turn, the providers assign them to the end users. So the Internet Assigned Numbers Registry, IANA, is the one that is responsible for distributing these IP address spaces. And they're distributed to regional internet registries, which are just other entities that are responsible for particular geographic regions. So in Africa, we have AFRINIC, which is responsible for all the number resources here within Africa, and APNIC for Asia Pacific, ARIN for America, LACNIC for Latin America, and RIPE NCC for Europe. So once the regional registries have these IP address spaces and the resources, an operator is able to then seek an allocation from them. It's assigned, and there is usually a fee to be incurred to use this IP address space because it is a limited resource, right? So for us to share it all equitably, someone has to pay for it. The other thing you need in order to do either peering or transit, or even have an ISP, is going to be having an autonomous system number, which is simply a 32-bit integer that is assigned by the RIR, which gives a unique identifier to a network. So for instance, in my network, I'm in Work Online Communications, we have 37271. So whenever you see that number anywhere on internet or in a traffic path, you know that that traffic at one point transited through Work Online's network. So usually the integer or the ASN signifies a network with a same routing policy. There's someone in charge of that network, and they have a routing policy to administer how the traffic will flow across that network based on various things, and business principles being one of them. At the end of the day, the internet is about making money. So this is just a diagram illustrating the delegation of the IP address resources. So that's the ASNs and the IP addresses. IPv4 as well as IPv6 is the same, is located in the same manner. Then next, another concept you want to understand is BGP. So BGP is a border gateway protocol. It's simply a routing protocol, and it's the one that is used throughout the internet. It's the glue that holds the internet together, right? How does traffic get from one location to another? It's simply because BGP is used to carry these internet prefixes. A prefix is simply just a collection of IP addresses, right? So when you say I have a /24, that's your prefix, whatever internet number plus the /24. So BGP as a protocol, it will learn various paths from the neighbors. So either internal BGP neighbors, which means they're in the same ASN, or external, meaning you're speaking to another ASN, which means another network, which you do not control. So it will, based on learning all these routes, it will pick the best path based on a certain criteria and insert it into the routing table. And it will only announce the best path to the external neighbors that it speaks to. Next, we have a POP, and a POP is just simply a location where a network operator can interconnect either with their customers or other networks. And this can range from a data center. I can have my POP located in a data center, which means I put some kit there which I can use to connect customers or other networks. And it can be in a building, at the back of a building somewhere. It can be at the top of a building for those who have like wireless services that they provide and the like. So now that we have kind of all those pieces together, we can now look at how peering and transit actually works. So here in the diagram, we have a couple of providers. We have A, B, C, D through F. And provider A, if for provider A to access resources, or for customers in provider E to access resources in provider A's network, there needs to be some form of interconnectivity between them, right? So in this case, we're assuming that provider A and provider E don't have POPs in the same location. So how does provider A then access these resources, right? So for this to happen, you could have another provider who's now provider B, who's going to provide for them the backbone. So they're going to be the one backhauling the traffic either across the city, across the region, across continents, whatever the case might be. So provider C is then able to offer provider A a service where they say, since we are both in the same location, I can give you a service where I'll carry your traffic through my network and connect you over to provider E or any other part of the global internet, whether it's to Google, Facebook, whatever the case might be. So that relationship is called transit. So in that case, provider A has to pay provider C, and likely provider E also needs to pay provider C for the service. And in peering, on the other hand, you would have two providers who are perhaps in the same facility. And they decide that, okay, since we have ours in the same location, why don't we save some money and not pay provider C to take us all around the world? Why don't we connect directly to one another? And we won't charge each other because it's mutually beneficial for both of those providers, ideally to be interconnected with one another. So that's basically the principle of peering and transit. In peering, you have a mutually beneficial connection with another provider, usually a similar sized network. So if it's a large network, two large networks will connect, maybe two medium-sized, two smaller networks will interconnect with one another in order to provide services. Another term we hear a lot over the internet is probably CDNs. And CDNs basically represents a content delivery network, which is just a geographically distributed group of servers that work together to provide the fast internet access to resources. So we know a couple of CDNs. We know like the Fastly's, Limelight, Akamai, and Facebook's and Google's, all these people who are carrying a lot of content on their networks and want to serve people. So taking an overview of how all these pieces now come together, this is what the global internet basically looks like. So we have some global providers here at the top, and these are the ones who have created or have deployed really large networks that span large geographic territories, and they're able to connect or have access to many, many other networks, either via peering or they're customers of theirs. And so global providers provide services to regional providers. So you have a global provider providing a service to a regional provider, maybe someone who is in Africa and they have a large network in Africa or Europe or wherever. And then you have now access providers who now are the ones who build the networks that serve people, the end users more so. So they're the people who will build metro networks, Wi-Fi networks within their geographies, wherever they're located, and they will probably likely get access from these regional providers. Then we have content providers as well, the Googles, the CDNs, etc. They also require some transit in some cases. So in some cases, they may need to pay another provider to get them to the users of their services, or in other cases, they could peer. So for peering, one of the most important things about peering is that it brings the content closer to the users. And by doing so, you actually improve the user experience. I'm sure everyone remembers when Google used to buffer away when you were trying to watch a YouTube video, which isn't common anymore because the content is coming closer and closer to the users. And here we see an IXP where we said an IXP is just a neutral location where many providers can actually come and interconnect with one another. So access providers and regional providers all come to the exchange point, And in some cases, we'll exchange some traffic locally with each other. And one of the most important things about peering is that it keeps local traffic local. You never have a situation where you're going to go to London, for instance, to reach another network in Kenya, while both networks are and both users are located in Kenya. So that's pretty much how the internet is made up. It's just a bunch of people who are either taking transit or peering from one another in order to get the whole interconnected mesh. So as we've spoken about, the value of peering is that it brings the content closer to the end users, and it really increases the resiliency of the networks. When you have a large cable cut in the ocean, you won't be unable to access local resources because there's an internet exchange point in Kenya. So there are actually two now. There's KIXP and there's Asteroid, which are available in several data centers at EADC and ICOLO. So for a network operator, the goal is to obtain as much peering as possible. Because if you have peering, then it means that you're paying less for transit. And that then in turn creates more access for people and higher bandwidth because of lower latencies. So once you're connected to an IXP, all you need to do is be in a location where the IXP is present, and you would either become a member and pay some fees to use a port on the switch. So the people who can be found at IXPs are access providers, regional providers, content providers and distribution networks. You have DNS service providers and other enterprises as well. So if you're a large enterprise and you're offering some service that is useful, it's important for you to be located at the exchange point. So your requirements for peering are simply to have an IP address space, an ASN, a peering DB record. This is just a record on the internet in a database saying that I have a network, this is my ASN, and these are the facilities I'm available in. And also in order to gain from peering, you have to be in the same location as a target network. So if I want to peer Google, I have to find out which facility are they in, and then take my POP to that location. Otherwise, I won't be able to peer with them directly. So when it comes down to peering and transit and how do you choose between the two of them, it's simply a matter of deciding the business case, because at the end of the day, it costs you money to go to an internet exchange point, it costs you money to put your kit in a data center and to have a circuit back to the rest of your POP. And also transit is also expensive, so it depends on how much traffic you can peer away at an exchange point or not. And at the end of the day, you have to do their own cost-benefit analysis for yourself. And with that, I can take a couple of questions.
All right, thank you, Michelle, for that presentation. So we move over to the Q&A section. I invite the attendees to post their questions on Q&A chat that are addressed to Michelle, and we can take that up. So there's a question from Young Mayodi asking, how is network operations at ISP levels adapting to DevNet?
DevNet, you mean kind of like, I'm assuming you mean like DevOps and kind of automation, I would assume. And if so, they are adapting and at different levels. So for instance, in our organization, our network is fully automated. So for any provisioning I need to do, any service turn up I need to do, it's actually just a matter of running an Ansible playbook against the network in order to effect those changes. So of course, a lot of networks are moving into the infrastructure as code and trying to do the automation of their networks. It's a process, and some are further along than others, but it's definitely the future of most network providers.
Okay, and there's a follow-up question still from Young Mayodi, who's asking, are scripts used for deployment or for provisioning? Michelle, you can take that.
Well, yeah, it just depends. Like in our case, it's probably a mix of some scripts in some cases. And yeah, so you do use them. It's just up to you. You have to write them at the end of the day, right? Even if you're having a playbook, if I want to create a playbook, there's no playbook that can run my network right now. I have to create it based on my network, put all my variables and my inventory into it for it to be actually useful to me on my network.
Yeah, so maybe just to add on Michelle's response, yeah, I think scripts is a bit general. What we can say is that run script if you have a goal to achieve, not just run a script. If you have two routers, you're running on a network, and then you don't have much services to do, then you might not need to run scripts. But you have networks, we have teams, organizations that are running network devices of say up to hundreds, 300 devices. Then you realize that if you wanted to change a policy, if you wanted to shut all the ports that are administratively up but they're not in use, then it's worth sending a script. So and if you have repetitive jobs, then you can run scripts. So I think it is on a case by case that you should be able to run scripts. Otherwise, it won't make sense. Yeah.
All right, thank you, Simon, for weighing in on that. There's another question from Alan Kipchoge. Let me request the attendees, please post your questions on the Q&A section so that we do not miss any of them or they don't get carried away, covered by the chats that are ongoing. There's a question from Alan Kipchoge, and he's asking, what is the role of a ring in networks? Michelle, you can take that.
Yeah, sure. A ring is basically to just ensure that you have network resiliency and redundancy. So if I have a ring, a fiber ring, for instance, it means if one path is unavailable, I shouldn't have total outage. It means I have another path that I'm able to use to get to the same destination, even if it might be a longer path. So it's very, very important for network resiliency.
Yeah, just addition to ring, different networks can have different use cases. We have different operators that run services to the access. So a case study of a network that I've operated is whereby we run MPLS to the access. And so the reason of the ring, in addition to Michelle's response, whereby it's for redundancy or protection, it's where also you pick services locally there. So whereby you're connecting to a metro ring. So in the case of Nairobi, you are in a location, say Chancery. You break out from there, and then there's also another customer connecting there. We don't have to go and meet at another data center like EADC or ICOLO, but we can be able to exchange traffic there and there as long as you're running like full services. But we have different deployments where people are running layer 2 only on the metros, whereby now you can only be able to exchange traffic at IP level at the farthest probably core pop for the provider. Yeah, thank you.
Awesome, good clarification there. There's one other question from Abel Nabiswa. And Abel is asking, what are the main factors ISPs consider before deciding to peer?
That's a really good question, Abel. So the factors you consider are, where is your traffic going? If I'm a network provider, I'd have to look at the flows in my network to determine where is my common destinations, where are most of my users trying to access, and that can really guide you into who to peer with, right? And then also the availability of an internet exchange point in my location, while it might be at a data center. There are other costs in that data center. So can I afford the cost? Does that saving I will make by peering also cover the cost I will have at being at that peering location? So I have to factor that in. There's the cost of a cross connect and the cost of membership to an IXP. I have to factor that in. I know that I have to keep paying for that. So it might be in some cases it's cheaper to just pay for transit. And in other cases, it might be cheaper or more beneficial for me to peer. But you should always peer whenever you can to keep the traffic local. Yeah.
Okay. So cost is a big factor there. There's another question from an anonymous attendee, and Anonymous is asking, who or which body determines the transit zones? Is it a commercial entity, or do the regional counterparts to IANA determine this?
No, no one determines the transit zone. A transit zone it's just a word for someone who's going to use their network to carry your traffic over it, right? If you're going over my pipes, which I've laid, for instance, I've built a connection Nairobi to Mombasa to Cape Town, right? You want to get to Cape Town and you're in Nairobi. Since you don't want to invest in having a whole cable of your own that goes from Nairobi to Cape Town, and I have already invested in that, I can offer you that as a service. So then you get to use my backbone to get from one point to another. So it's really a business thing, right? Someone can just decide, my job is I just want to build networks everywhere and allow other people to use them at a fee. Yeah, so no one says what to do. The internet is about people making their own decisions. That's why there's no one person who runs the internet. It's just all the networks coming together to provide some kind of service.
Okay, and there's someone here, anonymous, who's also seeking some clarification, maybe missed a part of your presentation, and is asking what makes peer-to-peer connection free. Maybe you can just clarify the criteria for what is free and what is costed.
Okay, so free, what makes peering free, or it is really that it's beneficial to both parties, right? That's why I said similar sized networks tend to peer with each other. If it benefits me to exchange, if we are two networks and we exchange a lot of traffic with one another, it's more beneficial for us to cut out the middleman, right? And say, you keep your costs, I'll keep my costs. Let's just exchange the traffic for free. But it doesn't mean it's free for you to get to peer, because like we said, there are costs to being at a location, right? But you won't pay each other. You won't have a business kind of, no one will invoice the other peer for, now I've carried 100 gig of your traffic. No, because it's mutually beneficial. Likely if you're doing 50 gig to me, I'm doing 50 gig to you, and we're both benefiting from it.
All right. Thank you, Michelle, for engaging and providing your insights. So we shall move on to our second presentation. Thank you, Michelle. We shall move on to our second presentation, and this will be done by John Gitao. John Gitao is an industry veteran. He's been in the industry for the last 15 years. And currently he serves as a system engineer at GPS Vodafone. He implements large-scale networks. He's well-versed with network engineer career paths, and that's what he will be presenting today. John, over to you. Please share your wisdom with us. Thank you.
You're on mute, John.
You're muted.
And now? You can hear me now?
Yes.
All right. Sorry about that. So yeah, my name is John Gitao. I hope you can all see my screen, the big one that covers the full screen, not the transition screen. All good?
Yes.
Okay. So yeah, thank you very much, Martha. My name is John Gitao, and as most of you who've been around the networking block for a while, you know, I've worked with quite a number of people in this group. It's always been my wish to work with younger engineers and see how they are coming up. I currently work at Cisco Systems, the global service provider team, and we basically work with some of the larger service providers across the globe. My main focus is Vodafone, and in Kenya, I obviously just work with Safaricom, We have a few other regional operators that I work with, but today's focus is really around the different journeys you are likely to take from a young engineer, with a key focus obviously on my specific journey, because some of these numbers and questions keep coming up in various platforms. So I've been since the early 2000s. I think around 2002, I joined Wananchi. And for me, I think I have to be honest here and say I worked a lot through, let's call it an apprentice model, where I went into Wananchi. I was told, here, our customers, go sell them dial-ups. As you sell them dial-ups, you have to support them. You're fixing their printer. You're fixing quite a number of things. Those days, we actually had to edit quite a number of, or write quite a number of drivers for. A good example is Unix. We didn't have drivers for most modems in Unix, and we had to do quite a number of those things. So yeah, I started in technical sales, customer support. Then I moved into engineering, and by engineering here, I mean I was allowed to tinker with things like BGP, basic routing, and from then I've never really looked back. I hold a current CCIE. I'm big on Cisco. I've always wanted to work at Cisco for a very long time. So I really, really worked hard, and I worked very hard to make sure I get into some of these positions. Today, I handle a lot of business strategy and such like conversations, and people from Safaricom who might be on this call know me very well. So yeah, I worked at Wananchi for about 4 years. I did Safaricom for about 5 years. And I'm in my 7th year at Cisco, which is quite long. I think this is the longest I've worked in a single company. But it's good, it's dynamic, I have fun. Along the way, I've set up a consulting company and exited. It's still going strong. I still check in to see what the guys are doing there. It's all good. I also focus a lot on emerging technologies. I advise the government quite a bit in some of these areas like blockchain, 5G, its deployment, and a few other areas like this. And yeah, I really enjoy the business side of things. And forums like this obviously help to keep things fresh for me. So far, since, again, it's important, I find that technology offers huge opportunities. I mean, there is no shortage of opportunities in technology. It's been highly satisfying for me. I've focused a lot on networking, but along the way, I've picked different skills in DevOps, like the questions you're answering there. I've done a lot with things like blockchain, AI, and a few other tools that we use either for work or for just fun. Technology gives you a lot of flexibility in career paths because it's very, it's quite open in the things you can do. By the time you understand how networkings work, SDN comes along. By the time you finish with this, someone is telling you about segment routing. By the time you're understanding this, AWS checks in, and there are all these cloud and cloud-like applications. By the time you understand virtualization, you need to be understanding what Docker is and other containers, and all these technologies work together. The other key thing we are seeing a lot of is that you cannot really separate business and technology. I can't think of a single business that is not using some sort of technology, even if it's just doing Lipa na M-Pesa, which almost any business I can think of today is using. It might look like just a few things you click on your phone, but I can assure you the guys who manage and maintain this technology will tell you how much complexity goes on, to making this easy for you. So it has a real impact across the board. And technology careers tend to retain their appeal over time. Since I started working, you'll find that for guys who know someone like Washington, who was pretty much my the guy with a kiboko telling you, set up this mail server this way. You'll find that some of the core principles we used to set up mail servers at that time still remain today. BGP, as an example, as Michelle explained, those, the core skill has not changed a lot. So that appeal for some of these things is actually retained. Most of the education is actually incremental. So it helps a lot to understand some of those fundamentals. Okay. For now, I won't really focus so much on whether you choose to be a programmer, networker, systems analyst, security. Like I said, it's open and you can do quite a number of things here. One of the other things I find quite important, I think, is there's this tendency, for instance, for a vendor to bring you this nice, shiny, dashboard, and you make your decisions depending on what your organization has trusted you to do. You might be making decisions based on things you don't understand. So the basics are important. Learn the OSI model, learn how TCP works, interact with people to understand some of these things. There's no way you are understanding some of the complex networks. Someone like Simon was talking about, when you have fiber to the curb, then you've layered your, layer 2 switches. If you do not understand, Ethernet basics, if you don't know what an Ethernet frame looks like, and you're confronted by something complex, then, you'll struggle quite a bit. And organizations pay for that skill. That's what you're paid to do, to troubleshoot that network, make sure it's up, make sure it's running 24/7, and things like that. If you're a programmer and you don't understand data structures, for instance, then you'll have problems. So these are important things to understand when you're young and when an opportunity presents itself. Various standard bodies like IANA, ICANN, bodies that support the internet, like the Internet Society, know their roles, know their place in the ecosystem. Read RFCs, especially the common ones. Understand how common protocols work. All these things are important for your future, and I can say they've served me well. Some of these are things I learned almost 10, 20 years ago, but confronted with a problem today, then, or seeing a problem, it could be some design solution you're working on, then you can figure out how to give advice based on, knowledge that you've accumulated over time. Again, understanding how things are set up from the basics, the complex. So today you might be setting up a simple 5-node network. In 3 years, you might require to set up a network spanning the entire country. These are all important skills to have. The last one is important for me. These meetups, like the one I'm in, like the one we're on today. I learned, I would say, more than 50% of everything I worked on through these programs. KeNOG at the time was pretty big. I think 3 years or 4 years after my first KeNOG, I was invited to become a trainer, something I thoroughly enjoyed. And by teaching, I actually, learn a lot, based on your questions and your interactions. I get to understand what's happening in the market, and based on this, you grow. Either way, I believe in learning by doing. So I don't believe sitting down and reading a lot will help you much. Get out there, build networks, commercialize them, make money. It's how you learn. I like going to IP space quite a bit. For guys who've been in the industry for a while, I think I found Ivan doing this, and he's still doing it. I think he's at probably 30 years plus doing networking. And one of the things he talks about is how you progress your career. And initially you start obviously by trying to understand and absorb as much as you can. Okay. I mean, you're seated there in a NOC at night, maybe you're doing support at night and you're reading, okay, so this is TCP, this is how you set up a mail server, this is how VoIP and all these WebRTC protocols work, etc, etc. And you have these sort of generalized general knowledge of a number of things, in a way that if your boss wakes up in the morning and says, "Oh, I would like to deploy a WebRTC based VoIP solution for our customers," you'll know exactly where to go and look and set it up. But typically, as you grow, you find an interest, you realize you're good at programming or you're enjoying it, and you start transitioning maybe your network, automating a few things here and there. And what happens as you grow, depending on your organization's requirements, is you're growing specific skill sets while still maintaining your general knowledge. The sweet spot for most is the space where you can actually, you're not really an expert in one very specific thing or just a generalist. It's a space where there is one or several things that you do very well that the organization actually requires. And you also have this generalist the knowledge. So at the top there, for instance, where it's written you cannot get paid for the value you can't add, it just really tries to go into. So let's say today you are the top expert in segment routing, for instance. There are very few networks deploying this sort of or in need of this skill. So you must actually be an expert in something nobody requires at the moment. It doesn't mean that this learning this technology is bad. It just means that you may not get maximum value for it over, let's say, understanding how to scale an MPLS network. Okay, so it's good to mix and match and figure out where you can add the most value. A good example, for instance, is learning and getting to understand cloud technologies today, knowing full well that in a few years, this is where everybody is going. So it may not be necessary today, but it's something you could use tomorrow. Another question that I get or I see coming up quite often is, and this was actually reminded, these are some of the things for me I take for granted, but from a very early point in my career, I actually started taking certifications. I think I had a CCNA in 2002, if I'm not wrong. Like I said, I was big on Cisco. It was the only routers, at least, I knew and worked with for quite a while. So yeah, and since then, I think I progressed through that path until I came and got in, got a CCIE, which was, at the time I was getting it myself, it was quite marketable. Today, there are quite a number of certificates. If you Google for top IT certifications, you'll find quite a number. Okay. But yeah, depending on your interest, I would definitely encourage you to go for certificates. Security, for instance, if you're a security practitioner, people really look at what certifications you hold. There are some very good certifications I find, for instance, for the certified wireless network professionals certificates. They are vendor neutral. They teach you pretty much everything from the basics, the fundamentals of how radio works, all the way to designing complex networks. And they also vendor certificates, like the Cisco ones, AWS, Google. Quite a number of vendors have their own certificates, and they serve their purpose. They make sure that they teach you how to use and work with the equipment. And I think to some extent, at least in my case, certifications have served me well. And it could be just for fun. Of late, I'm playing around a lot with tools for analyzing large data sets, specifically logs. And Elasticsearch is something I've been playing around with quite a lot. It could be Splunk, it could be anything. All of them, you have to research and make that decision. Degrees, yeah, I have one. For the most part, a lot of people discuss this. If you have an opportunity to, go through any learning process, formal or informal, I would encourage you to get one. You never know. It's part of, your career journey. It helps you network. It helps you talk to different people. For me, it's just one of those things. And I never really went through a full formal college experience. If you look at me and subtract how much I've been working, you'll realize I probably started working, I think, at 19 or 20. which means I actually completed most of my schooling while still at work. So different things, different paths, whatever works for you. But I would encourage you, if you have an opportunity to get formal papers, you can never go wrong. And yeah, occasionally I'll walk into a class and learn something entirely new. Maybe take a business class, finance, whatever it is. You never know where that could lead. But yeah, in terms of what you can and can't do with technology, I don't have to emphasize or to even mention that, everything is going digital. And I think the worst thing you can do for yourself is not put yourself in a position to take advantage of this. That's one, for yourself. And secondly, to help communities and the country. So if you look at the government, for instance, a lot of the citizen engagement has gone digital today. Everything from how government collects revenue to how they spend that money is digital today. And government alone presents a huge opportunity. It would be, if you were to digitize the entire government, it would probably be the largest distributed network we would have in this country, which I think would be pretty cool. And it's something I'm personally really keen on seeing happen. Enterprises, I don't need to even explain this. There's not a single enterprise that's not using technology. And of course, at individual levels, everything we do, from how we get entertained to how we get our kids educated today, everything is digital. So there's this huge scope and applicability for learning technology. The interesting thing, and I know this will probably raise quite a number of questions, is talk to any organization and most of them will tell you that they don't have good technical people. The interesting thing is, if you walk around even your street right now, out of 10 people, 4 will probably tell you they do IT. So there's an interesting, demand supply gap there. I don't know whether it's the skills or I don't know. In there, something happens where organizations claim that they don't have the best people working for them, but the market believes that they are the best in IT and technology and a whole host of other things. There are areas I totally believe to be true. Like if today you're looking for someone to build for you a simple web front end, we have quite a number of people doing this. But if you want a DevOps engineer to automate for you your network, maybe Michelle is hiring you people, then you'll probably have to do, a lot of internal skilling and a few things like this. But this is what the community is here to do. If the community wants help developing some of these skills, then we are here to help. And if we don't have the skills, we are able to bring in the necessary people to show you how to do these things. Salaries are actually rising in technology, and you'll be surprised, for instance, at how many people who are currently working in some of these large organizations are also freelancing on the side and making very interesting money. So you might talk to an enterprise today and they need a design for something, and you ping, I don't know, Michelle or Abel or someone, and they'll do this for you, small fee or large fee depending on their work. But you'll find that businesses actually need a lot more help. If you think about what has happened in the last maybe 3 or 4 months now, cybersecurity is a big problem. Parents have kids using technology in ways parents would never have imagined. But there's a very high chance both the parent and the kids don't understand how cybersecurity or how to handle some basic things about securing their networks. So how do we bridge that gap for even home users? Yeah, we need to bring them to a room or bring them to a forum like this and tell them, here's what you need to do. Number one, don't trust a connection just because you have it, or just because it's in your house. Don't connect any shiny gadget that you go and buy. Take them through this and show them. just to cover a few trends and myths, and I know you all have quite a number. Most businesses today, traditionally, and a good example is Wi-Fi. Even with customers or people I work with today, Wi-Fi was always that thing that they would design and not really bother with making sure that it works properly and it scales and this sort of thing. But today, someone who understands how to design wireless networks properly is being paid a lot, because one of the things that you'll notice is even in enterprises today, most of them are not using this. Remember how we used to have network points along walls and everybody would get a cable? Very soon, this is going away. It doesn't make sense for you to do this because wireless networks are quite good. So these technical skills are actually a key part of your business actually surviving, this century, for lack of a better, word. And for this, I don't believe that, number one, there are no technical jobs. Jobs are being created every day. When you are doing the blockchain task force, for instance, one of the key things everybody would come and say, yeah, these new technologies will take away our jobs. But it took us, and up to now, it's still something we have to explain, that technology actually creates new opportunities. It actually creates new jobs, okay? So jobs are actually increasing. Of course, some will be retired, but new jobs will be created. And the people on this group, the people working in these spaces are very well placed to take advantage of them. IT-related degrees and other vocational trainings are not worthless. I totally, truly believe in them. I support quite a number, and I want to see this growing. And I want as many people in this community to go back and actually support their vocational training centers. If any technical degrees, become lecturers. I think it's important that we keep creating a new pool of young engineers. Outsourcing will finish all jobs. This only works if you stop skilling yourself. There will always be someone to take your place. Unfortunately, these jobs will get done. But I totally don't believe in this. I think outsourcing, freelancing, and all these new, working from home, all these new models are just part of a bigger, larger ecosystem. And that networking does matter. And I will speak for networking because it's where I've made my career. It's where I started. And I don't believe I'm leaving this for a while. It matters a lot. It matters that you understand networking. And I'm talking about whether you think, if you're a developer who is writing a web application and you don't understand why it's slow and all this manner of things that affect your work, then picking a book and understanding TCP, for instance, at a very basic level, the difference between UDP and TCP, understanding those things will really work for you, at least help you innovate and keep things fresh. And yeah, the fastest growing salaries are actually associated with IT. You have to ask yourself at some point, when doctors start using, I don't know, remote telemedicine, who will support them if it's not you? So even as a doctor today, you need to understand IT. Who writes applications for Philips, for all these heart and insulin pumps? They're all people who both understood IT and technology first, and then understood the mechanics of how the heart or the liver and all these other things work. So this is not going away. It's actually going to increase. And yeah, so if I was to give any advice at this point, I would say, and this I can attribute to exactly what I did myself. As early as possible, aim to learn as much as you can, understand the fundamentals of everything, be it software, data structures, DevOps today, networking, systems design, intern if you can, volunteer, like we volunteer in this group, get part-time jobs, hobbies, freelance, anything to keep your skills fresh and, alive. Do all those things. And I think you'll be in a good position. As you progress and obviously get different interests, then start specializing, but keep an eye on the larger market and what's happening around you. A good example, I think, on this panel is someone like Kevin, who started highly technical, but now he's working at Internet Society, helping us with policies and other areas that you wouldn't really get to without this base. So develop your skills, get certified if it serves you, and if you get an opportunity to, get some soft skills. This is one thing I never used to like people who discuss business, leadership. I don't know. They're just, to me, I never used to understand what some of these soft skills mean, but I can't emphasize this enough. Exercise your leadership skills, get some business skills, and I think you'll go quite well. And at least you get, places to segue every once in a while. And then volunteer, teach as much as you can. I think I learned more teaching, preparing training material, webinars like this. I think I learned a lot more doing that than actually sitting down to learn in any specific class. And yeah, most of this is pretty straightforward stuff. You should never stop learning. Most of these things I'm sure everybody has told you. Graduate if you can, get some certifications. Don't be complacent, and this is especially for us older people. It's very easy to assume that you don't need to learn any new skills. I think it's more important than ever if you're going to keep your organizations growing and making more impact in the industry that you've chosen to be in. But over and above, have fun. We've had a lot of fun building networks. I have a lot of fun talking to customers about their networks and how they use technology, network widely. And that's all I had for you today. Thank you. Over to you, Martha.
Excellent. Thank you, John. As you talk about Wash and how much work he was giving you, I think back then I dreaded a call from you for support, because after talking to you, I would have to go and look for the next RFC to be able to give a substantive answer to whatever you are asking. So it is good to have such catalysts in the industry. Now let's move on to the Q&A section, and we will run through it fast so that we can be able to recover some time there. The first question is from Jeff Rono, and that's addressed to you, John. He's asking, whatever became of the government task force in using emerging technologies like blockchain? Is there a turnaround time in the implementation and adoption of such technologies?
Yeah, well, thanks for the question. And to answer this, so the task force completed its work. It submitted a report. Quite a number of projects have been identified. Some are ongoing. Some are actually pretty much complete. I need to go back and check. But generally for a task force, what you do is, you have this set of findings that give advice, for instance, to change some policy, improve specific areas. And where possible, we actually got lucky enough to see what the industry was doing. So yeah, in that sense, if you've not seen the report, please let me know. Martha will send you the link and you can share it with the community. And yeah, there are some interesting projects that are making use of some of these technologies, both commercial, some in government, and some in commercial entities. Thank you.
Sorry, we will avail more information on that. Labat, I can see your question, but I'll hold on that question for a bit. We will discuss this about the ring networks at the end, and I think all panelists will have something to contribute in that. There is another question from WB for you, John. How difficult was CCIE, and how many times did you fail before finally getting certified?
I passed the CCIE on my third attempt, actually. And yeah, I mean, in terms of difficulty, the thing with the CCIE and most of these high level certifications is if you've been working in an industry or with a set of technologies, then it's much easier than if you're just studying for the sake of passing the exam. But yeah, to answer your question, I did it 3 times. That time I passed, and yeah, the first 2 times were tough. You don't know what you don't know until you fail the exams after spending a bunch of hours and money trying to get it done. But yeah, it was an interesting trip over there.
Okay, and there is a comment here from Harriet Odima. Harriet, it's not a question, but more of an appreciation to you, John, an appreciation on the insights you have given towards growing in your career. She is actually in 3rd year and is a system analyst. And she agrees with you that most tracks in IT career are interdependent. Yeah, and
Yep.
yeah, so basically that's a comment and appreciation for the clarity. There's a question from an anonymous attendee. At John Gitao, what is your take on Cisco and Huawei competition in the network industry?
I think for a very long time we never really had other players in networking, and what tended to happen was if you wanted to learn networking, it was always Cisco or something open source on BSD or you know, I think it used to be Quagga or Viata or any of those things. Today, I think it's both a good and a bad thing in the sense that today there are so many vendors to pick from, including Huawei, who I think do a very good job with their networking products. A lot of times, just because I work at Cisco or someone works at Huawei, it's easy to assume that you like this over the other. First of all, the fundamentals are the same, and lucky for you, you know, they're interoperable. I know networks that are built, large networks that use both Cisco, Huawei, and other vendors. So for me, I welcome it, and I think anybody who uses both will tell you that it really helps to keep, you know, things like pricing and other things sane for the, you know, for the large part. So for me, I welcome any and all competition, and I believe the vendors themselves appreciate each other as much as they can. As an individual, for the most part, you should be able to work anywhere. I mean, I enjoy working at Cisco today. Nothing stops me from working at any other vendor tomorrow.
All right, okay. There's another question here from anonymous, an anonymous attendee, and is asking, does a course in optical fiber play a big role in networking? And if so, how?
Well, look, there's nothing like wasted opportunity to learn. On this panel, I know quite a number of you who started in companies that were doing fiber. So yeah, by all means, if you're working in a company for who optical fiber is part of their core business, then by all means go out and get the courses, the certificates.
Okay, and there's a last question here that we'll take before we get into the next presentation, again from an anonymous attendee, asking, what is your take on the LTE self-deployment kits? Have we even scratched the surface on this?
So this radio space is very interesting. It's only recently that, again, it had been dominated by the same players for a very long time. But today, what you are seeing is quite a number of movements to open it up, okay? To the extent, so if you look at 5G, for instance, I think most networks that will be doing 5G will probably have 5-10 vendors. And some of them might even be open source radios. So in terms of have we scratched the surface on this? No, I think we are still going to see a lot of innovation in that space. What I think about self-deploy kits, I've not used them myself. I would leave this comment to someone who actually works actively in that space. But it's something I'm actually very interested in seeing. If anybody looks at something like what Open Run is doing right now, then you will realize that there's quite a lot is happening in the background in this 3GPP arena.
Okay, thank you, John, for that very interactive session. We do hail you as an industry expert, and I think that has also come out through the session, giving insights and very useful feedback to our attendees. And without further ado, I would like to invite our third panelist to make his presentation, Mr. Simon Mayoe. Simon is a network architect at SICO, which operates a global MPLS backbone, as well as submarine cable systems between Africa, Europe, and Asia Pacific. Simon has 10-year experience in the service provider space, and he's heavily involved in community organizations such as TZNOG, AFNOG, as an instructor. And Simon is a strong supporter of good netizenship to keep the internet clean. With his expertise in IP MPLS networks, Simon is certainly the person to take us through how to develop IPv6 implementation plans for ISPs. And with that said, Simon, please take it away.
Thank you so much, Martha. You can see my screen?
Yes.
Okay, thank you. Yeah, thanks so much. Simon is my name. I work with SICO. I'll just delve into the slides. So I'm talking about how to develop an ISP IPv6 implementation plan. Of course, we have a very short time, and it will be more of just a high level. The slide will be based so much on SICOM as a case study because this is where I operate from. So some background information about IPv6. I'm sure this is a technical webinar. We know what an IP address is. So we have a previous IPv4, which is 32 bits, and then IPv6 is 128 bits. If we have to get more about this one, I think this will be arranged in other webinars. Because of the IPv6 being 128 bits, it gives us quite a huge addressing space. So it has millions of addresses. I can say almost inexhaustible, but it's not a reason to misuse. Because I think once upon a time, IPv4 addresses, we used to say there's so many. If you are given a /12, you could say it will never be depleted, but now it's history. This is just an example of an IPv6, how it looks like, and how you can easily subnet the IPv6 addressing scheme. These are /32. I've tried to subnet it into a couple of /36. We have a myriad of tools on the internet for use for subnetting. At SICOM, we use a mix of both IPv6 gen. It's more of a tool running it's just a script we're running on Unix servers, running on PAL. And we also back it up with what we call rack tables. It's basically open source. We are moving soon to networks because of the ease of automation and how flexible networks is. Then Reasons for IPv6 plan deployment. I think for one, I can say readiness for IPv4 exhaustion. We know that we've had announcements of different regions running out of IPv4 addressing scheme. Only Africa is remaining with a bigger chunk, and the bigger chunk is now smaller. If you apply now for IPv4 addressing scheme, you cannot be given more than a /22. And so if you're planning for a big deployment, it might have a limitation, and it's a bylaw. There's no way you can be able to go around it. You'll be given a /22, finish it, go for another one. So basically, because it's going eventually, very soon, probably before end of this year, maybe you not be able to be given more than a /23. So one of it is preparation for IPv4 exhaustion, because once it's exhausted, then you can't say I can't operate a network. Yeah, you might be required to run a purely IPv6 network. Okay. The second reason that for us we had to deploy is to stay ahead of customer requirements. We know of customers who normally come with a very urgent service activation. They need this particular service activation. So we better be ahead so that when they come, it's just a matter of activating, not testing, especially when you have competition running such protocols. And then the other one is reduced dependency on a single protocol. We've had a situation whereby we have an outage or a DOS attack on IPv4, but still we have the capability of managing the box. Why? Because I can be able to reach it via IPv6. And so because of the way the deployment has been made, being like dual stack, there's a full separation of between IPv4 and IPv6. None of them is dependent on the other. Okay, so just a high level on how we have done the addressing, the IP addressing planning and all that, the way we deployed on our network. We acquired a /32. That is what Afrinic is offering, like to start with. They can give you a bigger block than that if you justify. I don't recall if it's still until now, but they have been giving it for free as long as you have an Afrinic resource. So for us, we got it for free. Then we had to subnet it to a couple of /48s first, and then we divide them. So we say one /48, we reserve it completely for loopback addressing. So that if I ever come out of CCOM and then my son eventually joins CCOM 15 years to come, we will still have a couple of loopback IP addresses that you can be able to allocate without having to start segmenting any, because they are many out of the /48. And then the way we normally set up our policy is loopback IP addresses /128. If you remember, IPv4 is /32. And then for point-to-point, we choose to go for a /126. Most networks we see point-to-point IPv4, they do /31s to reserve allocations because of the depletion. And then we have another subdivided another block of a /48 for network-wide core network infrastructure. So we have our core network, our routers, switches, and all that, whereby the interconnections between those devices. And then we have as another /48 per pop. So in any scenario, if you are probably a local provider, you could have multiple pops, one in Nairobi, one in Mombasa, one in Thika, and all that. So for our case, since the infrastructure is in different cities and say countries, we have a /48 allocated per pop for infrastructure and customer point-to-point link. So if a customer comes, we allocate them a /126 out of this particular pool. And then we get another /48 per pop again submitted for onward allocations for customers. So if a customer wants a pool of IPv6 addresses, we give them from that. And then we have another /48 assigned for network-wide servers and services that we have on the network. And with this, I think we've not, out of the /32, we've not reached 2% of usage because they are many addresses. Okay, next, our implementation strategy, we have a couple of them. You can go with dual stack, you can go with the translation like NAT64, you can go for tunneling. We went for dual stack, and the reason of the choice is to make it simple and scalable. And the other reason is to make IPv6 independent of IPv4, so that anything that runs on IPv6 does not, its fate is not in the hands of IPv4. Like, for example, if I say something to do with the 6PE and all that, that means if we have some brokenness on IPv4, then even my IPv6 network is down. If a POP goes down on IPv4, then that means that's it. I cannot be able to reach it. But having clear separation makes it very, very independent. Okay, then some considerations prior to deployment. Just verify that IPv6 support on the installed kit, so that the installed kit, the kit that you are running, supports. Remember the days when people started with CCNAs and all that, we used to have boxes called 2500s, I think 2600s, which of course, and I mean, it's interesting that I'm talking about Cisco. I think Cisco was a universal provider then. And so such boxes, most of them, they do not support. Cisco no longer develops software on that particular platform. So you can't say that I want to support IPv6 on such platform because they're not developing for that. That's just an example. So just make sure that the kit supports IPv6. Then the deployment, the deployed equipment vendors on the network, the best practice is that you be vendor agnostic. Do not have a dependency on one vendor. Okay, because if you have a dependence on Huawei, they'll push boxes and lock you in. I like saying that we don't run like proprietary protocols, like if it's it comes to SDH interfaces running something like was it called HDLC or the likes? Why? Because tomorrow, if I want to replace the Cisco with Juniper, I do not want to see or understand if it will work properly. Then just to list a couple of softwares that connects to, I mean, that are for specific vendors that support IPv6. We have iOS for Cisco, we have Junos, we have EOS. Seacom runs a multi-vendor network, and these softwares, they do support IPv6 unless you're running a very old box. Then you need to have, sorry about that, to take consideration on the protocol that you're running. If you're running like an IGP, which is OSPF, you need to know that you are running OSPF v2, and then for IPv6, you have to enable OSPF v3. If you're running ISIS, which for us we run ISIS, then be sure that when you turn up IPv6, you'll be better placed to run multi-topology instead of single topology. It scales properly and brings the separations clear. Make sure that you have licenses. Licenses is now where vendors get the money. Somebody remembers an old Cisco box used to be called 2800. You could run everything on it. You can run call manager on it. You can make it a firewall, everything. But Cisco became clever. They took it away. Personally, I've been importing some to use them on the lab because I can use them for anything. But you can get them from like Europe for, last year I got one at $60, a full router, 2800. Very interesting days. Requirements prior to deployment. Since you want to deploy IPv6, you'll need to get an allocation from your internet registry. I think Michelle talked about a couple of IRRs, that's internet registries, which are continent-based. We're in Africa, so we use Afrinic. In Europe, they use RIPE and CC. In Asia Pacific, they use EPNIC. Americas, they use, North America, they use ARIN. And then South America, they use LACNIC, that is Latin America. So you have to acquire a block over IPv6, depending on the policy that they have in that particular range. You can be in Africa, and then you go to EPNIC for allocation. Setup configurations. So this is based on dual stack setup using ISIS. as the IGP with all devices supporting IPv6 routing and with proper licenses of ISIS. I say all devices supporting IPv6 routing because some devices might not be supporting, but you really want to turn on. And so you can have a strategy to migrate or start integrating, like redistributing and the likes. So prerequisites on IPv6, I've considered a couple of vendors, but this particular one is for Cisco because these features are not enabled by default. So you'll have to enable IPv6 self, IPv6 unicast routing, no IPv6 source route, and then no IPv6 redirects, no IP, then you do IPv6 IND suppress, then multi-topology. Most of these, they have not been enabled. Different vendors, they enable different features by default, but some do not. Okay. This is just an example, an output of the configurations for two vendors. We have ISIS. This one I'll just run quickly because you cannot be able to like grab everything, but you receive slides. We have iOS for Cisco, how to set up ISIS, and then for Junos. Then we have BGP for iOS, and then for Junos, and how to configure multi-topology. For both vendors. And then you have the static routes because of the BGP setup. And with that, you will be ready to run IPv6 in your network. But now you need to connect to the internet. So once IPv6 is implemented in the core network, as indicated in the slides, next is access to the world. So using your route registry like Afrinic, you create some of the route objects or orgnams. This is an example of the SICOM's allocation, whereby the route 6 is created as a /2, so that it is recognized on the internet that you are the one who is the owner. Of course, it does not really apply nowadays. Sometimes people can hijack your routes and all that, and that's why we have implementations for security like RPKI. Now that one is a discussion for another day because it's longer. Then once done and BGP set up with the upstream providers, you should be able to receive a full BGP table, IPv6. I've just given an example of one of the SICOM routers in a border router in London, whereby we have both IPv4 and IPv6, just indicating that we are doing dual stack. The full BGP table for IPv6 is down there, where it's showing count lines is around 85,000 lines. But of course, IPv4, the full table is slightly over 800,000 routes as per yesterday. All right, just an easy way to be able to troubleshoot your network. I did run a trace route from one of my devices in Mombasa to the internet. I tried to Google because I know Google also runs IPv6. So they do IPv6 they do dual stack. And so if you can check, my hops are uniform, where I live from hop 1 to hop 6, all of them, they are uniform, whereby I'm going hop by hop because I'm running dual stack. IPv6 routing challenges. This is just a graphical comparison of how the deployment has been. In Europe, it's very much done properly, but in Africa is little. So it's really an encouragement for African networks to be able to deploy that. And we have many forums that can be able to support that. And that's about it. Thank you so much.
Fantastic. Thank you, Simon. That was a very condensed presentation and very informative as well. If anyone wishes to get in touch with Simon just to learn more about IPv6, you will see the contacts of the various panelists, and you can engage with them further. So quickly jumping into a Q&A session, but before we do so, I'd like to let you know that we have a poll session that is running. Please share your feedback, and with that, we will understand better where you're coming from, what are your thoughts about this presentation, your career path, and any other areas where we can improve on. So please, there goes the poll. Kindly assist us with that information. I hope that all attendees can see the polls. And I'd also like to say thanks to Barack and quite a number that I am seeing heavily engaged on the chat session about IXPs, about improving the kind of education and the skills that we're imparting to our teams in the various counties. All right. Yes, I can see the feedback is coming on the polls. Thank you very much. All right, and as that goes on, I would pick up a couple of questions and in the interest of time. The first question is from Labat. I had pushed it to the end, and Labat is asking, in addition to the question about rings, importance of rings in networks. He's asking, apart from ring networks offering network resilience and redundancy, it leverages traffic engineering paths, basically routing your data to preferred path based on its QoS priority level as a way to mitigate congestions. Actually, it's not a comment, but it's not a question, but clarification and clarification on ring networks and how they add value. Okay, I can see some questions coming in. Anonymous attendee asks, all the panelists, thank you for your great and insightful presentation. What is your advice to young engineers like me who are looking for opportunities in the industry? Are there any internships or job opportunities for recent graduates in your company? I think for that question, maybe the panelists can just type in if you know of any opportunities, and maybe you can also type in on the WhatsApp group, and anyone who has feedback will probably be able to assist you there. Okay, the second question is from David Wangombe, and David is asking, what are some of the key security considerations to make before deploying IPv6? Maybe Simon, you can take that one, and John, Michelle, please feel free to weigh in.
Yeah, thanks so much. Yeah, so I like saying that IPv6 actually itself is not security, as I think some people have time said. But of course, there is a level of security itself whereby some host addresses you cannot really like be able to predict as for IPv4, because the way I subnet might not be easily predictable. But what I can say is I think security on the network needs to be made wholesomely. So if you're running like your IGP protocol, just make sure that you've secured properly, MD5s and all that. If you're doing ISIs on the point-to-point links, make sure that it's strictly on point-to-point. Make sure that you guard your network so that it is not hijacked. So all your IPv6 routes, make sure that you implement technologies like RPKI, because that is one of the most secure security measure as we speak now when it comes to BGP, so that no one can be able to hijack. We have seen YouTube, big companies like Google, whereby their YouTube was hijacked a couple of years ago. Last year, some other networks also were hijacked. So the best way is to make sure that you secure so that on the internet, you are the one who is the authentic originator of your network, if it's IPv6 or IPv4. So run all the security protocols from, all security on all the protocols from the IGP all the way to the protocols that run on the internet, like BGP.
Okay,
I think the only thing I would add to that is that for those who run firewalls, whatever rules you have in IPv4, you have to put the same in IPv6. Otherwise, you're not actually protected.
Thanks, Michelle. John, any wise words to add?
Well, most of it has been said. I think the first thing you need to realize is there's a very high chance that by just enabling it, you expose your IPv4 applications, and it's easy to forget that part. I think also learn, most of the gaps, most of the reasons you'll have security issues is you probably don't know enough, or you're working with people who don't know enough. So it's important to understand these protocols as early as possible, how they work, how they get integrated, and that sort of thing. But yeah, I'm sure we'll be having more detailed V6 sessions so we can go over some of these details.
Okay, thank you. I can see there are quite, at least half of the attendees have put in their feedback on the polls. I encourage those who have not done so to please provide us with feedback. It's anonymous and it's geared towards improving these sessions. I can see also there are no more questions for now, but we have an ongoing WhatsApp group. Kevin will share the link shortly to invite anyone who would want to join us there and to continue the discussions. So to close this session, thank you, Michelle, Simon, and John for your input here. Thank you, Kevin, for introducing KeNOG to those who did not know about it and those of us who knew about it but did not understand the background and where we are going. And in the wise words of Henry Ford, if we move forward together, we will be successful. And in this journey, and over the last 1.5 hours, we have been moving together, we have been interacting, we have been discussing various matters. And so for sure, success will come. The only variable there is the time. This webinar is recorded and it will be available on the KeNOG webpage for later viewing if you would like to review any of the matters discussed there. The presentations will also be shared to you. The feedback from the poll, we shall also give you that information once we see we get the feedback from the remaining attendees. I wish to thank Kevin and Mercy, who have worked round the clock to disperse information to the right people at the right time and to take care of the back end. I wish to thank the committee members because you have put in your time to make this webinar a success. As you heard from Kevin, KeNOG did not start this year, but goes back to 2018. And so we have had sponsors who have carried us through that. And we thank you very much for coming through. The audience, thank you very much for participating, for engaging, for your thoughts, for the chat that has been on fire quite a bit. And without your attendance, let me just note, it would have been a very boring session. So this discussion is not ended. We will continue this discussion on the WhatsApp group. Please join us there. And with that, see you on the other side. Thank you.
Thank you, Martha. Maybe just before we close, there's one more anonymous poll that is running. As mentioned at the start, we'd like to organize a more in-depth tutorial. We'd like to know which of the topics covered today would be most interesting to you. So it's an anonymous poll. Kindly feel it should be displaying on your screen right now. Just let us know which of the three we should consider for the next in-depth tutorial, and we'll confirm the date and time of that in the WhatsApp group. Thank you. Thank you very much. We look forward to engaging with you on the WhatsApp group.